In this video, I'm going to do these 4 questions, which is based on these standard limits. These 3 standard limits is what we'll be using in solving these 4 questions. So let's begin with the first one. In this question from the NCRT exemplar, we have to evaluate this at limit x tends to 1. First, we can observe here that this is in the form of 0 by 0. As you can see, if I replace x with 1 over here, so this is 2 into 1 plus 2 into 1 is 1, right? 1 plus 1 minus 3 is equal to 0. So we have to eliminate the factor, and we will do by method of factorization. So in the first code I'm doing, I'm factorizing the denominator. This is from the factor of 6, right? We have to obtain 1. So this is clearly 3 and 2. So I'm going to factorize it. This is minus 2x plus 3x minus 3. And if I take 2x as common, it is x minus 1. If I take 3 as common, it is x minus 1. So if I take x minus 1 as common, we'll get what? 3x, 2x plus 3, right? Now you see here, if I write down the question, which is under root x minus 1, and this is 2x minus 3, that whole divided by this is x minus 1 into 2x plus 3 after factorizing, and this limit here as x tends to 1. Now check here, we can factorize this further. We can factorize it and write it as, let me show it, the working limit x tending to 1. This is under root x minus 1 over 2x. This is 2x plus 3, right? Not, yeah, they cannot be cancelled. This is 2x minus 3 and 2x plus 3. So let it be as it is. And this, as I said, I can factorize it. And I can write this as a minus b into a plus b. Right? This is, I can write this as, basically I wrote x as what? Root x whole square minus 1. So this can be written as a plus b into a minus b. This is root x minus 1. So, and that multiplied by, this is 2x plus 3. Now check here, this get cancelled, right? This get cancelled here. So you can see that 0 by 0 form gets cancelled. Now I'm placing the limit x as 1. This is 2 into 1 is 2. So 2 minus 3, and below it is under root 1 is what? 1. 1 plus 1. And this side it is 2 plus 1. This is 2 plus 3, sorry. So what we'll get finally in the numerator, we are getting what? Minus 1, and the denominator, this is 2 and 5. That is 10. So it's minus 1 over 10. That is B is the correct option in this case. So question here is, if limit x tends to 2, x raised to the power n minus 2 raised to the power n over x minus 2 is equal to 80, then we have to get n is equal to. So here we'll be applying the standard limits as limit x tends to ax raised to the power n minus a over x minus a is what? N x raised to the power n minus 1. So this is what I'm going to apply here. Let's say if I apply this thing, this formula. So what is n? N is n here, and what is a? A is what? 2 that raised to the power n minus 1, and which is equal to 80. Next, what I'll do, I'll just do prime factorization of 80 so as to find its factor. So this is 2, 40 times 2, yeah, that's 2, 20 times 2, 10 times, and 2, 5 times. So this is n2 raised to the power n minus 1, and I can write 80 as what? I can write 80 as 5, that multiplied by 2 raised to the power 4. Right. So we can compare, right? As if you compare, we can say that the n is what? From here, n is 5, right? Comparing these two, we can say n is 5. You may compare these two also, like the powers over here to verify, that is n minus 1, right? If I compare n minus 1 with what? 4 over here, right? So therefore, let's check out what we are getting here. In the first comparing these two, we are getting n as 5. Now to cross check it is n minus 1 when compared with 4, n comes out to be 4 plus 1, that is 5. So yes, so 5 is the correct answer. That is option C in this case. We have to evaluate this function at limit x tends to 0. And for that, we'll be using this standard limit, but not before substitution. So what we are going to do is to replace this, or say put 1 plus x as y. So we can say that as y tends to, you can see y tends to 1 as x tends to 0. Why? Because as you know, the limit here over here will change. Now let's say if I write down the function now, the function will turn as what in terms of y now. This is limit y tends to 1 over here, and this will be replaced with what? Y over here. So this is under root y, which is y raised to the power half minus 1, and that divided by x. From here we can get x as what? From here x is y minus 1. This is y minus 1. So 1 raised to the power any number is 1 only, so we can write 1 as 1 raised to the power half. Now check, you can apply this standard limit over here. So now we can say this is equal to n, which is half here. This is n is what? Half. Into a is 1, that raised to the power half minus 1. So this is 1 raised to the power minus half. So which you may write as 1 over 1 raised to the power half. So 1 raised to the power any number is 1 only. So half is the answer in this case. So we'll say yes, B is the correct option in this case. In the next question, we have to evaluate this function sin x over tan x and limit x tends to 0. For that, we'll be using these standard limits, that is tan x over x when x tends to 0 is 1, and so is limit x tends to 0 sin x over x is equal to 5. Now check here, if I, what I'm going to do, let's say this is limit x tends to 0. This is sine 7x. So I'm going to divide and multiply by 7x. Let's say I divide it by 7x and I'm multiplying by 7x. And below we have limit. This is same limit, that is tan 5x over, if I divide by 5x and multiply by 5x. So you can figure out from here that these x and x get cancelled. So I can write 7 over 5 outside and applying limits over here. So as you can see in the numerator, I can write, since x tends to 0 implies what? 7x tends to 0. This is sine x over sine 7x, right? This is not sine x, that is sine 7x over 7x. And below, if I apply the limit separately, as x tends to 0, 5x also tends to 0. This is tan 5x over 5x. Now check here, this is going to be 1 and this will also be 1. So 7 multiplied by 1, 7 by 5 multiplied by 1 will results to give you 7 over 5 only. I can see that B is the correct option in this case.